Well, hello and welcome to my garage. As you can see behind me here, I have a mini shell. This started life as an 83 Mini City E. It was a typical barn find. It's been in a barn since 1999. I think that's when the tax ran out when I first got it. Usual Mini of that era really. Lots of rust, all the fronts, all the boot, sills, A-panels, door skins, all the usual bits. Been cut out and replaced. Everything was stripped to bare metal. 2-pack epoxy etch primed, followed by a high build primer. This needs just a bit of finishing off. Maybe one more coat of primer plus the top coat. I'm doing some work inside at the moment. Put the roll cage in. That's going to go continued on with, stripped out, and I can start doing the final paintwork. But the purpose of this, hopefully the series of videos I've just started is all about putting the Nissan CG 1.4 litre Micra engine in this particular car. There's quite a few videos out there showing Nissan engine minis. There's nothing new about that, but they're all shown complete, so I thought I'd just do a few videos just to show you what I'm up to and the steps really that you need to go through to get a subframe modified and an engine fitted. Also, as to hopefully with the episodes progress, I'll speak about the modifications that you can do to them, and you'll see how mine's going actually. So that's where we are. So I'll just take you through what I've done today. So, those of you who wish to do this sort of modification, putting a Micra engine or otherwise into an original mini front subframe, the first thing you have to do is build yourself a jig to support the subframe in. Now this one, as you can see, it's already been modified, so just for clarity, I'm not sure how this is going to come out on video, but the silver parts are the existing subframe. There's a bit on the right hand side which I'll come to later, which is the new part I've put in. But if it's brown, dirty and or rusty, it's or red in fact as well, it's actually part of the jig. So I'll just walk you around to show you how this was done and some tips if you want to do one yourself. So if you're going to build one of these, the first thing to do is make yourself the rectangular picture frame. You obviously measure the subframe first. I'm not sure what this one is, probably about 3 foot, perhaps a bit more wide, and probably about 2.5, maybe 3 feet back to front. As I call that picture frame, I just use a bit of 50mm angle frame here. If I was making a recommendation, I would use box section for certainly most of this. This bottom part just for the strength and rigidity more than anything. The next step is to put in these vertical piers here, one each side, making sure they're plumb, weld those into place, and then I put a piece of, again, 50mm, very, very stiff and thick angle from one to the other. Ignore the bit missing, I'll come to that in a second. And then the next thing you have to do then is drill the holes using existing tower bolts to bolt the subframe to the jig. That's the first thing. Once you've done that, you've got a choice. You can either make the front mounts or you can make the rear mounts. Now the way I've set mine up is that the original pieces, which I'll show in a sec, which were in here, I set those up so they were level. I just use a normal spirit level, which shows the towers then lean slightly backwards. It's just easy to use that as a reference. So the next step is put the front mounts on and the rear mounts. Again, if I was building one again, I'd make these a bit stronger than they are. There's a little bit of flex in these, and flex in a jig is very undesirable, so I would probably triangulate these mounts a bit more to get a bit more strength in. And similarly, the back, in this particular case, is strong enough for the job. So that's the jig. That's to make sure all 6 location points remain fixed in space. Now the subframe, when you start with it, it's obviously going to look a bit more like this. This is a piece just put back in the subframe, just to show you what's required. But there's quite a bit of measuring to and fro with the engine at this point. I was basically lowering the engine to the subframe area and working out what the cuts needed to be, and worked out, you know, a reasonable sort of distance working from the tower forward. But I need to move a section about this sort of size. It turned out to be a little bit bigger in the end. And likewise for this side as well, the passenger side, I cut out, you know, good 250, possibly a bit more, 270mm. Not actually measured it. And likewise, the back of the differential is a fair bit of the subframe you have to remove here as well, to get enough space for the diff housing. So those are the 3 points of cut really. There's a little bit around the front here you have to cut out for the bell housing, and there will be some more on this subframe to cut out the front here for the exhaust downpipe to go through. There's one thing I forgot to mention when I was talking about the jig earlier, and that's its height in the jig. And I'll just come and just show you something. The distance from the top of this jig here to the bottom of the subframe is about the same as it would be on the Rover, as it turns out. So it's actually fitted to the car. That's the ground clearance you're dealing with. It's quite a useful thing to have when you start building, rebuilding the subframe itself with your new engine in. So it's just good to have that distance just to keep focused on what you can play around with. So once you've done all your cutting or what you think needs to be cut on both the passenger side, the driver's side and the rear, it's time to get your jig. This is what I've set up. I think I find this quite useful. Is to set the jig up on a standard engine crane, as you can see. So what you can do here, and you'll end up doing this many times in terms of refining the process, is to lower the engine in, do a trial fit, often lift it, cut a bit more out, trial fit again until you get enough clearance all around the engine. I aimed for about 10mm as a minimum clearance to any metal part of the subframe. So I'll just go off camera, lower the engine to its final resting spot. I know exactly where it needs to be now, and I'll show you some useful datum points to measure off. So after all the cutting of the subframe and lowering the engine into it, this is how it should look. People may want to do slightly different things with their particular installation, so it may vary a few mil either way. In this case I've just put a couple of pieces in of the rebuild of the subframe to put the strength and structure back into it, but I've left the key parts off just for the moment, for you just to see how it sort of unfolds. So I'll just go around, just talk you around things. So here at the front, this angle iron plate is a temporary engine mount which is just used for alignment purposes, nothing more. The real thing will look quite different than that. It'll be a rubber mount using a Range Rover, Land Rover mount. I'll show you one of those in a second. That plate down below, just here, is a plate I fabricated. Likewise, the one at the bottom here is one I fabricated that goes under the subframe, and everything was built off that, linking the back of the subframe to the front of the subframe. And then this plate on the top here, this particular one here, is where the top mount will, the engine mount will fit, and also the structure will link up to this plate as well, and that'll be heavily reinforced with a bit of box section beneath, and I'll show you that in a later episode. Moving around the back, you can start seeing the issue now with the differential. It is comparatively bulky. I'll just zoom into that area. Comparatively bulky, so it does require a fair bit of the subframe being removed, and one of my jobs at the moment is just finalising the structure to put back into that area to bring the strength back up to where it ought to be. Again, I will show you that. And what's not helped this particular installation, the engine I've chosen and the gearbox that came with it is from the 1.4 Micra. I did actually want the slightly later 2002 engine, which actually has a capacity of 1348. So there's an extra few Cs, hopefully make a bit more power. But the downside is the gearbox is different to the 1.3 CG engine, and it is bulkier, so doing this installation is a bit more tricky. So here, just set up this view so you can see how this sort of starts shaping up. This bit here, this dark member, is part of the jig, so ignore that, that's just to hold everything together. This bit of 25mm box section and this box section here, which is drilled out, just trying to save a bit of weight hopefully, and this reinforcement gusset here is just basically linking the back of the subframe to the front, and then underneath the gearbox, linking again the back to the front, there's a 50 by 25mm box section which has been cut and shaped to fit beneath the gearbox again, leaving about 10mm clearance around everything. So things are tight. Now, one of the crucial areas when you do this install, and things are made more difficult as I mentioned earlier with the later 1.4 litre gearbox, it is a bit more bulky than the 1.3, is clearance from the drive shaft. I'll just get a close in shot just in this area here, which did cause me a little bit of concern when I was cutting, because I knew the cutting was a bit drastic looking, but you have to do it, I'm afraid. So I'll just show you that. So this view here is looking from the passenger side in towards the gearbox, into the differential area, and where the drive shaft would normally sit, and you can see there's not a huge amount of room in the subframe area for that drive shaft to fit through. One of the little things I've found is that the CV gate is a bulky part, makes it quite bulky, is that you can get various boots. I think the ones I've looked at so far off Renault's tend to be a much slimmer boot and will fit the Nissan drive shaft hopefully. So I must look into that in a bit more detail. But this area here, because I've cut so much out, I've now got to put the strength back. So there's a big member underneath, and it'll be linked top to bottom as well with reinforcement plates to pick up on the suspension points, so that hopefully strength is returned back to where it should be. Okay. One thing that's useful to note as well is just this little plate on the top of the gearbox here. That's purely a temporary mount, just to hold the gearbox in place whilst you're taking key measurements and starting to make your brackets and do your alignment checks. So back to the bits you need to make. I've just set these up on the bench. These are all to go on the subframe. They've all been made, trowel fitted, clamped in place, checked for clearance, all around the engine. And this is what you end up with. These are the sort of bits and pieces. So the one I mentioned earlier, just a couple of minutes ago, the cradle around the gearbox, this is it. This is what it looks like. So a bit of 50mm by 25mm box section, rectangular hollow box. Underneath, just a few lightning holes, just try and keep the weight down a little bit. As you can see there, just back in shot. That's just tacked together at the moment, so I need to fully weld that up. And that'll be welded in place, seam welded in place. Again, it takes a bit of time to do that. It's a fair few, well, I won't say hours work, but certainly more than a couple of hours I would think to produce that. There's a sort of level of detail you need to go to get everything to fit and replace the strength that you've lost. So these are all the bits I've made so far. I think that's probably it. The only thing that's missing from that pile of bits there is the actual mounts, engine mounts that fit on the engine itself. So that'll be featured again. What you find on a project of this type, well I found myself at least, that the project tends to sort of evolve really, of a bit of cutting, a bit of re-strengthening, putting brackets in place to make things work. And I'm just sort of showing you here the solution to the rear end of the subframe, put the strength back in there. So just to show you the new points, there's three uprights here, which I've just left a gap there just for illustration. This piece on the top of this bit of 25mm, again everything's 3mm wall thickness, will mount between the two towers, both sides, and then it will also join to these three pieces here. In addition, there will be a reinforcement gusset in the corner that will fit and hopefully give a bit more strength. And then these particular two, if you're wondering what those are for, that will hold a plate on the other side which will hold the engine mount, and the engine will have a receptacle arrangement. So that'll be the rear of the engine sorted. And then, as I mentioned earlier, there'll be another mount which will fit beneath this plate here. So you've got two mounts at the back, and if I need to, there's also a point here where you can use as a steady bar. Similar sort of setup to what the A series engine has, and there'll be two mounts at the front. So the mounts I'm using are these Range Rover, Land Rover mounts. I think they're fitted on most of the vehicles up to the V8. They are extremely solid. One of the reasons I chose these is because they are solid. Available on eBay, they're about £6 or something, quite cheap affair. And I think they're 79-80mm diameter and probably about 35 high. So they're fairly compact, but the aim on this particular install, because everything's so tight, is to keep the movement of the engine to a minimum, save any interference with the subframe itself. So yeah, these are the ones. Like I say, I think I'm using 3 of these, plus another mount at the bottom here, and then possibly a steady bar. So there'll be a minimum of 4 mounts, plus a steady bar. I think when it was fitted in the Nissan, it had one each side, one at the front and the centre, one at the rear, so there's 4. But they were, relatively speaking, quite a squidgy sort of mount that allowed a fair bit of isolation, quietness and so on. One of the questions that get asked is what do I intend to do with the engine once I've got it fitted and installed in terms of modification. Well, the standard, this particular engine, it says the later 1.4 litre engine, produces about 82 horsepower, which isn't a huge amount by any means. Initial thoughts are to go a turbo route. It will depend on packaging. This engine version now, the Mini, with the round front on in particular, is quite tight. There's a limited amount of space. I've got a cooling radiator to probably front mount, which leaves a bit less room for an intercooler, and turbo pipe plus the turbo plus the exhaust. So quite a few things to think about in terms of space and what it will take up. So that's one route. I'm still looking at that, and I think with a modest amount of boost I should be looking at possibly 150-160 brake horsepower from this engine. It's supposed to be fairly tough, very reliable, strong engine. Red lines are about 7,300, so it's fairly strong, comfortably. And they certainly have a good reputation, that's for sure. And the alternative to the turbo route is to possibly consider throttle bodies off a motorcycle like a GSX-R. They seem to be quite a good solution in the sense that the spacing of the ports on this engine, the Micra engine, and the GSX, Suzuki GSX engines is the same, so the throttle bodies do need to match up with the ports exactly, or near enough exactly. And there are manifolds available quite readily. There's at least 2 suppliers in the UK I can think of. It's fairly straightforward to make your own if you wish. But for £120 or thereabout, it's quite easy to go off and buy one. So that's an option. I think the throttle bodies should give about 25% more power over the conventional injection on this engine. There's cams available for it. Piper, I think, do cams, fast road cams, which give about 12 horsepower more. Hopefully there'll be a bit of gain in the exhaust. This car doesn't need a catalyst, of course, so there's probably about 3 horsepower advantage there. So the standard engine, even without the catalyst, should produce about 84-85 horsepower in theory, and also better free flowing exhaust as well. So I would think these engines should be good on, natural aspirated engines should be good for probably upwards of 125 horsepower, maybe 130 if everything's in good condition and it's been set up well. This car, it started life at 620 k's, the Mini City E. You've taken some weight out. The front's all going to be fiberglass, aircraft grade fiberglass. It's very light, likewise the bonnet. Booted glass fibre. So that's weight I've taken away. Interior will be quite sparse. Plan to put carbon fibre seats in, minimal soundproofing, no rear seat. So very basic sort of setup. The weight I've added over standard is the cage. That's fairly heavy than it looks in fact. But apart from that, not a lot else. Other weight saving measures, I'm going to go for plastic windows and doors, partly because of the reduction in the glass to plastic, but the big reduction, of course, is in the winder mechanism within the door itself. That's surprisingly heavy, so that'll go. That's a bit more weight. So, all things considered, if I can get all-up weight lighter than it started, 620, that'd be really the 600 mark is what I'm aiming at, just because it's a nice round number. So with the 120, 130 horsepower, hopefully around about 150, 120 the wheels, it'll be a pretty lively thing, I think. Okay, so till next time, I'm going to close down.